Okay, this is some more trigonometric equations from section 5.5. This is number 17, the tangent of x equals 0. So I know these graphs pretty well, so I kind of think of the graphs as tangent graph, and you can see right here the tangent of x equals 0 when the tangent is 0. That's actually the vertical position when the x value is 0, right here. This is the tangent of x. So I know that that's going to be, the solution will be when x equals 0. And we talked about this before, because the tangent has a period of pi, we just keep, in order to get all the solutions, we just have to multiply by n pi. I'm not multiply, but add n pi. And that's all you have to do. In other words, it's 0 when n is 0, it's 0. When n is 1, it's pi. When n is 2, it's 2 pi. When n is 3, it's 3 pi. When n is negative 1, it's negative pi. All those will give you the tangent of 0. And you can check that on your unit circle. Just keep going around your unit circle. So relatively easy. Number 19. Okay, and number 19 is, okay, would be when I go down the bottom of the paper. It's a little longer one. That always works out. Well, maybe we can still use all of our paper to get this to work. Okay, so we have number 19, a little more complicated problem, but we've done some of these before, I believe. So we've got 2 cosine of x plus the square root of 3 equals 0. So first of all, we want to just isolate the cosine of x. So if I subtract the square root of 3, I get 2 cosine of x equals negative square root of 3. Then if I divide by 2, cosine of x equals negative the square root of 3 over 2. All right. Now we know this, if it's the square root of 3, the cosine of what is the square root of 3 over 2, that's just going to be pi over 6, right? So that's pi over 6. In other words, the cosine of pi over 6 is the square root of 3 over 2, but we're in negative quadrants because it's negative. So cosine will be negative in the second and the third quadrant. It's going to be pi over 6, but only pi over 6 in the second quadrant is 5 pi over 6. So x can equal 5 pi over 6. And in the third quadrant, that's going to be x equals 7 pi over 6. So you have to know those quadrants and where they are. And this is where the cosine is equal to a negative value, and this is the square root of 3 over 2 is one of the 6 in the denominator values for cosine. Okay? Except what's the period of the cosine? 2 pi, so we're just going to add 2n pi. And that's going to give me all the cycles of that for all integers. Okay? So that wasn't too bad. All right? Okay. And let's try number 21. Okay, number 21. 4 sine theta minus 1 equals 2 sine theta. Okay, let's take a look at this one. 4 sine of theta minus 1 equals 2 sine of theta. Well, first of all, I'll just group my sine theta. So if I subtract 2 sine of theta from both sides, so minus 2 sine theta theta. Then 4 things minus 2 things is just 2 things, so I just have 2 sine theta minus 1 equals, and then something minus itself is 0. Okay? And then the same thing, I'd add 1 to both sides, so I got to isolate the sine theta eventually. So that first step would be to add 1 to both sides, and then divide by 2, so I get the sine of theta equals 1/2. Well, there we go. The sine of theta is equal to 1/2. That's going to be basically just pi over 6. The sine of pi over 6 is 1/2. All right, so that's why we really spend a lot of time working on that unit circle. So we know that theta can equal pi over 6, because it's positive there. Oops, pi over 6, excuse me. And it can also, theta can also equal another 6 in the denominator, where it's positive, and it's positive in the second quadrant. All students take calculus, so it's also going to be positive in the second quadrant, so that's going to be 5 pi over 6. Okay, we can read that. Okay, pi over 6 or 5 pi over 6, except we have, this is periodic and goes in both directions, so what we'll do is we'll just add 2n pi. There you go. So that's number 21. Okay, then number 23. This is the last of this little exercise type. Okay, number 23, 3 sine of theta. 3 sine of theta plus 5. Okay, 3 sine of theta plus 5 equals negative 2 sine of theta. Okay. Alright, so first of all, I'll try to get all my thetas on the same side, so I'll just add 2 sine theta to both sides. And 3 plus 2 is 5, so I got 5 sine of theta plus 5 equals 0. I guess that's all right. And then I'll try to isolate my sine theta, so I subtract 5 from both sides. So I've got 5 sine of theta equals negative 5. Then if I divide both sides by negative 5, by 5, I get the sine of theta equals negative 1. Okay, so where does the sine of theta equal negative 1? Well, basically, I kind of drew the sine of theta over here. So this is my sine curve again. And you can see it equals negative 1 over here. And this is going to be 3 pi over 2. So theta can equal 3 pi over 2. Okay, and this is one of those points where it's just going to have one solution per period. It's going to be these negative 1 and 1. They're just one. Otherwise, there's 2 solutions per period. And then the next one will be actually 2 and 2 pi later. So it goes through all this again until it's negative 1 again. So it goes through another whole period. So I would just be adding 2n pi. Okay, and that's all you really have. Okay, because it's one of those nice values where you just have one solution per period. Okay, and that's just that when it's ever negative 1 or 1, that's when that occurs. So that's your answer. Okay, right over here. Okay, hope those help. Not too difficult.